Welcome to another Macron Group webinar. My name is Charles Zona, and I would like to thank everyone for attending today's webinar. Our presenter today is Jeff McGinn. Jeff is going to tell us about JEOL's new scanning electron microscope, the NeoScope. But before we get started, I'll give you a bit of Jeff's background. Jeff is the President and Chief Operations Officer of both Macron Microscopes and Accessories and Hooke College of Applied Sciences. Jeff teaches portions of our modern polarized light microscopy courses and has a keen interest in chemical microscopy. He is also well versed in scanning electron microscopy and helps to solve customers' analytical needs on a daily basis. Jeff will field questions from the audience immediately following today's presentation. This webinar is being recorded and will be available on the Macron Group website under the Webinars tab. And now I'll hand the webinar over to Jeff.
Thanks, Chuck, and good afternoon, everyone. Again, my name is Jeff McGinn, and today I'm going to talk about the new JEOL JCM 6000 Plus benchtop SEM. This is the third generation of this exciting instrument, and over the next 10 to 15 minutes I will discuss some of the key features of this microscope. Benchtop scanning electron microscopes have come a long way in the years since they were first introduced, with capabilities including magnifications up to 60,000x, multiple accelerating voltages, and both secondary and backscatter detectors. These smaller versions of full-sized SEMs are finding their way into more and more industrial and educational laboratories. Here we have some of the key features of the JCM 6000 Plus, starting with the overall size. A very small footprint. It fits onto any common laboratory bench and plugs into a standard outlet. You don't need to build out a special room or reinforce a floor for these types of instruments. It has a combined tungsten filament and cartridge type Wenalt. It has real magnification up to 60,000x. I highlight real magnification because other benchtop SEMs on the market only go to about the 30,000x range and then higher with a digital zoom. Resolution around 15 nanometers on this instrument. It has both high and low vacuum modes for a variety of conductive and non-conductive samples. 2 imaging detectors, both a secondary and a backscatter. It's the only benchtop SEM on the market with 3 accelerating voltages, 5, 10, and 15 kV. Has a large chamber and accommodates samples up to 70 millimeters in diameter by 50 millimeters high. It has a tilt-rotate motorized sample holder, tilts 15 degrees in one direction, 45 in the other, and a full 360-degree rotation. Then there's a couple options for the JCM 6000 Plus. A fully motorized XY stage, and an EDS detector, which I'll talk about more later. The JCM 6000 Plus has been designed to cover a wide range of applications, and these next 3 slides focus on some of our more common applications, such as semiconductor and polymer research. And on this slide here we see 2 images taken of the same field of view, one under secondary imaging and the other under backscatter. Here's another image of a semiconductor sample taken under secondary and backscatter imaging. Note the differences in contrast, particularly on the backscatter image, noting the changes in elemental composition. And here we have a nice representation of some of the higher end magnification and resolution capabilities that the NeoScope can achieve. We've got 2 images here of polymer nanofibers, both under secondary electron imaging. One on the left is at 10,000x and the one on the right at 20,000x. Workflow on this instrument is key, and JEOL has designed a software and overall functionality geared towards ease of use. A sample can be loaded, chamber evacuated, and image displayed in less than 3 minutes. Instrument control via the software can either be done in the automatic mode or manually if desired. As I mentioned in a previous slide, we have placed these instruments in full-on research labs with experienced scanning electron microscopists, as well as quality control labs, and with users with little or no SEM experience. We can fully train someone and get them up and running in less than an hour. Once again, software control is simple on the JCM 6000 Plus. This intuitive system features automatic and manual controls, all to control beam alignment, focus, stigmation, brightness, and contrast. It has an auto filament on-off functionality in order to preserve filament life, as well as preset magnifications. Observation conditions are also fully controllable, including probe current, accelerating voltage, high or low vacuum capabilities. The system comes standard with touchscreen functionality, perfect for a modern-day generation used to using iPads and iPhones. Maintenance on the JCM 6000 Plus is as simple as changing a light bulb. Cleaning and centering are not required, and axis alignment is automatic. The tungsten filament on this instrument can be changed in less than 5 minutes. Overall, today's benchtop SEMs contain many of the same features as their larger full-size cousins. With multiple accelerating voltages and both secondary and backscatter detectors, these compact instruments provide the user with more flexibility at a lower cost. The types of signals produced by the JUL JCM 6000 Plus include both secondary electrons and backscatter electrons. Secondary electrons are inherently low in energy and come from the top few nanometers of the sample surface. Secondary electron imaging can produce high-resolution images of the sample surface. Topography dominates. Since the intensity of the backscattered signal is closely related to the atomic number of the sample, backscattered imaging is particularly useful in providing information about the distribution of different elements within the sample. Brighter areas are indicative of denser, higher atomic number materials. The all-new NeoScope now offers both an Eberhard Thornley type secondary electron detector as well as an improved high-sensitivity solid-state backscatter detector. This improved solid-state multi-segment backscatter detector features 3 imaging modes: composition, topographic, and shadow, which is a combination of composition and topographic. Here we see an image of a lead tin solder and the unique differences between a secondary image on the left, note the topographic information, and the backscatter image on the right with the notable differences in elemental composition. One of the most exciting features of the new JCM 6000 Plus is the improved solid-state multi-segment backscatter electron detector. It features 3 imaging modes: composition, topographic, and shadow. Shadow is a combination of composition and topographical information. Here we see 3 images, same field of view of a business card. Note the differences in elemental composition on the compo image, surface enhancement on the topo image, and the combination of both in the shadow feature. Measurements are also very easy to perform with the JCM 6000 Plus, and one can make direct measurements on the live image itself via the touch screen or on saved images. Measurements are exported as CSV files. The JCM 6000 Plus also allows for the ability to compare a live image with a saved one. And here we see a saved image on the right, taken with a stereo microscope, imported into the NeoScope software and compared with the same field of view in the SEM. This can also be done in a quality control setting, as live images are compared with reference standards that have been captured previously. New to the JCM 6000 Plus is a motorized XY control stage. And here on the larger image, we see the view position of the stub on the software pop-up window. When we couple this new motorized stage with the standard tilt-rotate stage that we see here on the upper right, we can achieve 4-axis motor control: X, Y, tilt, and rotate. Perhaps the most powerful advancement to the JCM 6000 Plus is the full-featured energy dispersive X-ray spectroscopy detector, or EDS. This analytical technique is used for the elemental analysis or chemical characterization of a sample. The EDS process detects X-rays emitted from the sample during bombardment by an electron beam to characterize the elemental composition. Features as small as 1 micron or less can be analyzed. And some of the key features on the JCM 6000 Plus EDS are a 10 square millimeter silicon drift detector, guaranteed resolution of 133 eV or better. It has an ultra-thin window for detection from boron to uranium, offers full area, partial area, multiple point, and line scan EDS analysis. It can acquire up to 32 elemental maps simultaneously at 4096 by 3072 pixels and offers drift compensation. Equipping the JCM 6000 Plus with this powerful analytical technique enables scientists the ability to fully characterize their samples and to identify unknowns at the fraction of the cost of a full-sized SEM. Here we see an X-ray map with detected elements highlighted on the pop-up periodic table. Again, one can perform detection on a spot, area, line, and with the X-ray mapping functionality. The powerful EDS software allows for report generation and places images, spectral, and experimental conditions onto a Word, Excel, or PowerPoint document. One of the many exciting things about the Macron Group is that in addition to our analytical services and instrument sales, we also offer training courses in a variety of microscopy techniques. When we provide a JCM 6000 Plus to a customer, we always include expert installation and instruction. But we also offer a 5-day intensive SEM course. This 5-day course is completely hands-on and covers things like SEM setup and operation, EDS qualitative and quantitative analysis, and imaging techniques. We encourage you to bring your own samples for use on one of our many SEMs here at Macron. The JCM 6000 Plus is also used in the course. And with that, we have come to the end of my presentation. Thank you for your time today. And Chuck, I think with that, we're going to take a few questions.
Yeah, thanks, Jeff.
Yep.
We have some questions rolling in here right now. Let's see, from James. Can you compare the JCM 6000 Plus to a full-sized SEM to help him understand where the limitations might be with like between JEOL instruments?
Okay. Thanks, Chuck, and thanks, James. Obviously, a full-size SEM has a higher magnification range. Some of them go up to a million x, a million times mag. The NeoScope, or the 6000 Plus, only goes up to 60,000 x. It has 3 set voltages of 5, 10, and 15 kV, whereas on a full size you may get a much wider range. So,
okay,
that helps.
Yeah, that's a good question. From Andy, what does the full-size SEM have that the JEOL does not? So kind of along the same
along
lines.
the same lines. It's really more the magnification capabilities. Resolution as well, obviously. As I mentioned, the resolution on the NeoScope is near 15 nanometers, and you can certainly achieve much higher. I don't want to say better, much higher with a full-size SEM. So,
and Andy also followed up with the accelerating voltages that are available.
Yeah,
again?
on the NeoScope, they're 5, 10, and 15 kV.
Okay.
It does high and low vac. So.
Okay, and then from Jan, are the XY coordinates of a particle on, let's say, a filter stored so that I can make several pictures and stitch them together?
You know, I'd have to get back on that question, Jan. The motorized stage, that's a new item, and you can't store the coordinates on a basic stage. So, but I think you might be able to do it on the new one. So let me check on that and I'll get back to you. I think it's possible, but I'm not positive.
We're, let's see, from Stefan here, were the business card images coded, or were they taken using a variable pressure SEM?
They were coated. They were coated with a fine layer of gold, actually.
All right, from Kirk.
Yeah.
Would you say that obtaining an SEM would benefit the biology, chemistry, and physics departments at any university?
Yeah, certainly. And you know, I think Chuck can probably talk about that too. Many of our students here, you know, they are students at local colleges, so, and they use SEMs, and we've seen a lot of schools that don't have SEMs, and this is certainly a cheaper way to utilize this exciting science.
Yeah, to get it kind of on campus, so to speak. And
exactly. Yep.
Yeah, we've had, you know, physicists, physics professors, biology professors, chemistry professors attending our SEM courses, and yeah, I think it would find a wide application. Let's see, from James, is the motorized stage and Xray standard now?
Well, they can be. You can purchase a benchtop SEM, the NeoScope, with or without those items. So, I mean, they're listed as basically an option, but yes, you can get it with both.
Okay.
Here's one from Brian.
Yeah, Brian's asking, do you think this product is a necessity for a pharmaceutical company in the identification of their particulates?
Yeah, that would be a definite yes, and I would say that probably 75% of our customers are pharmaceutical scientists. So it's a benchtop instrument. It's quick and it's easy. You know, as I mentioned before, you don't need to build out a special room, and you can move it from lab to lab as well.
Okay, from Kirk again, is the 5-day course only available with the purchase of the SEM system?
No, it's not. You can take the 5-day course without the purchase. And Chuck, when's our next course scheduled for? Our next 5-day SEM course?
Third week in October, I believe.
October 24th through the 28th, I think.
Yeah,
so
it is a very popular course. We do limit the number of seats as to give people the most hands-on instrument time possible. So we try to keep the class small, but yeah, it's available to really anyone out there who's interested in learning about scanning electron microscopy. And get one more question here from Andy.
Another one from Andy.
Yeah, what are the recommended conditions like humidity, temperature, vibration, shaking, he mentions?
No, there are really no recommended environmental conditions. We place our instrument on a standard lab bench. We've We've traveled with these before. We've put them in the back of our car and traveled with them. Not that we use it there, but yeah, you should. It needs to be in a standard lab. That's all. You don't need to monitor temperature or anything like that. And if it's on a sturdy table, vibration is never an issue.
All right. Well, I think that's going to do it for the questions, Jeff. I'd like to thank everybody again for attending today's webinar, and be sure to join us for our next webinar on July 21st, when I will actually be the presenter, talking about our 3+1 academic partnerships in microscopy. So we hope to see you then. Thank you.
Thanks, everyone.